So like they say, if you can't touch it, you cannot break it. Or the developers say, if I can't touch it, I cannot build it. If you are here, you are in the cloud adoption journey, somewhere on that journey where you're trying to figure out what's that happy medium. When do I approach that happy medium? I am Harvinder Nagpal with AWS, and I'm joined here with Valentine, my colleague Valentine, and also Jagmohan from Merck, and Alex from Fidelity Investments to talk about how do we strike a balance between least privilege and business agility. So we're going to talk about what are the different mechanisms that are available from AWS on securing the services, enforcing least privilege model, and then we'll also hear from Jag and Alex on their journey, cloud adoption journey, how it's evolved, and how over the period of those years or that evolution, they have evolved their access models to be more business agile and nimble. So as the cloud adoption journey begins, right, the cloud transformation journey begins. Some of you may be on the initial stages, some of you may be in the middle stages, some of you may be in the very advanced stages. It presents its own opportunities and its own challenges, right? Whether it is about multi-account adoption, segregation of workloads, or using it as an ephemeral infrastructure. Now, the whole point is we want the business to innovate. We want our data scientists, business analysts to think and evolve, right? But with the goal of keeping the dangerous actions, preventing the dangerous actions, right? And making sure that the security posture is not compromised. So in that sense, what do we have? So AWS has the services on to protect and secure who can access what, right? And not only who can access what, but provide that infrastructure around the overall management through cloud governance for the entire AWS ecosystem in there. It also provides AWS IAM services, also provide services like Access Analyzer, which can help you with the identity hygiene, because you cannot protect what you cannot see. So you want to analyze what the users have access to, what your services have access to, and then secure them even further. So there are some foundational best practices when it comes to enabling it on the AWS environment, whether it is using your multi-account strategy to innovate faster and securely, setting up the secure landing zones through Control Tower, and doing workload segregations so that your workloads which are on different risk levels or sensitivity levels can be in different AWS accounts and secured appropriately, and access can be managed appropriately. The other one is deploying those secure guardrails at an organization level, AWS organization level, so that no matter what the business or the developer can work on within their, for the lack of a better term, the playground, then they are able to work on it in a secure way. And then you can secure them through either the organizational guardrails like SCPs or using data perimeters. The whole point is you want to develop a mechanism for defense in depth. And that's what Jag and Alex are going to talk about when it comes to these preventative, detective, and remediative controls. So when you talk to different teams, right, I'm sure some of you are from the centralized teams like the Cloud Center of Excellence or the security teams, information security teams, and some of you may be from the audit compliance team or just the governance, cloud governance teams in there, while some of you could be from the decentralized teams like the data scientists, the developers, the business analysts. And all of them, when you talk to them about what does this least privilege mean to them, the answer may vary, right? So on the security side, they really want to secure, provide just enough, very minimalistic access to the users, to the services, so those users or services can just do their job and not anymore. Whereas the developers, the business stakeholders, the data scientists, they want to evaluate new services, right? And they want to come up with the innovative solutions using cloud native technologies faster and quickly. So where does that happy medium lie? What does this least privilege model mean to them? Where does the needle lie? Who is responsible for it? Is it the Cloud Center of Excellence, the centralized team, or is it my business team, right? And who defines it? At what point of time is it defined, and how is it enforced? That's the whole point about, is it an art or is it really a very methodical mathematical science? And now I'm going to pass it on to my colleague Val, who's going to talk about the various mechanisms available from AWS.
Thank you, Harvey. And so, as Harvey mentioned on the last slide, when we talk about security, agility, and least privilege, it's a balance. And so in finding that balance, we find ourselves looking for the sweet spot. And so the sweet spot is often can be found in three different areas. First, you have the prevention of overprivilege. And overprivilege is when an identity, either a human or a machine, receives more permission than is intended. One way overprivilege can happen is that the identity has not been guardrailed from taking undesirable actions. And so with this, you want to prevent overprivilege so that your identities stay within their security contexts. Now, with just enough privilege, this is when an identity has the privilege necessary to achieve its current and future outcomes. This means that not every outcome is strictly defined. Instead, the job function and role have been defined, and the identity has the ability to operate within that understood boundary. And finally, we come to least privilege. This is where actions for an identity have been strictly defined, and the security context is tightly scoped to only allow activities within the predefined outcomes. And so as we go through these next few slides, we will be describing different controls that you can use to achieve these different outcomes. And remember, as was stated before, sometimes this is an art and not a science. And so what this means for you is that sometimes the feature or service that provides least privilege in one use case may in another use case be used to delegate just enough privilege. At AWS, we talk to customers who are at every stage of the cloud adoption journey. Within this cloud adoption journey, there's also a privilege model journey. On the left-hand side, we are talking to customers who are deploying their first workloads on AWS. On the right, we have customers who are innovating and modernizing their business. When you're starting on AWS, you want to build the foundation for your organization. This foundation provides a platform for you to deploy your workloads into. You will enable services that provide guardrails. You will provide your workforce with access into AWS, and you will monitor for external access to your AWS environment. And as you progress to the right on your AWS journey, you will be migrating workloads to AWS accounts. You will be deploying new workloads into accounts. Here, you will be developing guardrails and applying least privilege concepts to your applications and workloads. You will be using both network and identity controls to achieve this. And finally, as you modernize and innovate on AWS with our cloud-native capabilities, you will develop mechanisms to allow you to safely delegate privilege from a centralized place to your workforce who are operating on AWS. This allows them to innovate in their own environments that don't violate your security invariants that you've defined. And so it's important to state that these aren't hard definitions. They're indicators of where you may be on your cloud journey, and how you define that will define how you grow your least privilege models. So starting with your foundation, a cloud foundation allows you to enable services to help you manage your AWS accounts and workloads. Foundational services include Control Tower, which offers you a straightforward way to govern and manage your AWS accounts. Services and features, such as AWS organizations, allow you to manage your AWS accounts. Service control policies allow you to set those guardrails on AWS accounts. With IAM Identity Center, you're able to securely connect your workforce into AWS to allow them to operate. And then finally, you can use services like IAM Access Analyzer to identify resources in your organization that have been shared with external identities. And over time, you can generate IAM policies based on your AWS CloudTrail logs. As you migrate and develop your workloads into AWS, you'll then be applying least privilege concepts to the workload that you're deploying or developing on AWS. And so this example shows a logical diagram for a typical 3-tier web application. For workforce identity, they're going to log into the account using IAM Identity Center. For S3 buckets, you can apply S3 resource policies onto the bucket to only allow CloudFront to access the objects inside S3. As you move into the application with application load balancers, you can use VPCs and VPC endpoints. VPCs allow you to launch AWS resources in a logically isolated virtual network. And with VPC endpoints, you can provide granular access control in a one-to-one service-to-service interactions, in this case with EC2 to DynamoDB. And now finally, we get to modernization. Modernization and innovating on AWS is where you're going to be delegating those permissions and really empowering your workforce to innovate at scale. And so here, you'll be monitoring for misconfigurations, unused privilege, overprivilege. You can develop auto remediation, and with auto remediation, you're able to, at scale, fix problems as they occur. Of course, you'll want to make sure that these methods are tested and validated with humans before automating, but it's part of the least privileged journey. You'll then establish your data perimeters. With data perimeters, you're going to make sure that your application only has access to the resources that are intended. And finally, you'll shift left with infrastructure as code. You can use tools such as CloudFormation Guard to identify security issues in code before it gets deployed into an application or into an AWS account. By shifting left in this way, you can anticipate and detect problems and save work in the future. So going back to this idea of finding your sweet spot between security and agility, when you think about the personas who are working with AWS, think about where you are here. Perhaps you're part of the Cloud Center of Excellence or a centralized cloud team. Oftentimes, we see that these teams are very much trying to prevent overprivilege for their organization. They're defining those security invariants and those boundaries. Now, if you're an application developer and you're developing or migrating workloads on AWS, you need to have enough privilege to do your job, but you may not need full AWS admin to your environment. And so in that case, you need just enough privilege where you can do your job and security is not a blocker. And finally, on the right, with the idea of least privilege, when you're able to define and tightly scope the security requirements of an application or a workload, you can get to the point where you understand the security invariants and you understand the outcomes that you need and can truly scope the application to only access what it should access. And so, with these concepts of personas and shifting left and DevSecOps, I want to invite Jag from Merck to help describe to you how they are doing it on AWS.
Thank you, AWS. It's a privilege to be here. Hello, everyone. I'm Jag Huda from Merck. I'm a product manager for cloud platform security, and my main responsibility is to improve on cloud security posture and security automation. Merck, as you might know, Merck is 130 years plus old company where we are bringing hope to humanity by the development of vaccines and medicines. Merck is a global pharmacy company. Overall, it's a research-intensive company. And like many of you, we are also on our transformational journey. So transformation cloud journey project that we are today is called as Blue Sky. This project comprised of 4 paths. Number 1, rehost, retire, modernize, and value. It means all the applications which are adding some value to the cloud or some value to their usage are only migrating to the cloud. Today, our agenda is, let's talk about our cloud journey and how we innovated at scale. How did we utilize comprehensive security capabilities to stay compliant? What were the challenges and opportunities on our way? Now, as we started in 2013, we started with fewer shared accounts, and today we have hundreds of dedicated accounts as an enterprise. We had time-consuming account creation process, And today we have a fully automated account workflows. We'll talk about that in the details. We moved from request-based approach, that means creating the tickets for even any minor request. And today we all have the self-enablement process. Along the way, we also created the standardized service enablement process. Initially, we used to have a limited alerting for security, and today we have a continuous compliance process. All this helped us in the acceleration of our cloud journey, cost reduction, risk mitigation, and adding the business value. Now, migration and this modernization also comes with some challenges. And we also had along the way modern challenges. So, for example, increased demand for the more accounts every day versus the lack of resources was one of them. We didn't have enough preventive and detective controls in place. Cost containment was an issue, and we also felt the need of better cloud governance. So to adapt to the consumer demands quickly and provide them accounts rapidly, we basically created the agile organizations. We provided ability to increase the pace of experimentation by automation and self-service models. Security is built in each layer by default. So along with that, focus teams are created for resilience and cost optimization. Now let's talk about an example. As I mentioned, we have a research-intensive company, so any scientist or any researcher has an idea or a use case for predictive modeling. So they would like to train their model with a different type of data sets. How they can realize that use case, we'll talk about that throughout this cloud. So now let's look at that. Initially, once we understand the account workloads, once we know what is the use case overall, we have a cloud enablement flow that gets initiated. That means we understand their architectures, what is the better services, AWS services they can use, all that basically establishing the requirements from the consumer, enablement of the flow, and the architectural approval process. Then we create new accounts as per the attributes provided by the respective consumer. Along with that, once we understand the workloads, and all those workloads are deployed using secure templates. So we have established outlined guardrails. We have created the self-service IAM strategy. We'll talk about that in a minute. And we have preventive, detective, and responsive controls are in place. Along with that, we also have the a drift detection in place, security alert notifications, and we provide self-compliance as a service model for overall visualizing or orchestrating, you can say, all the non-compliances. Now, as I mentioned, our journey, we were creating our accounts manually. So multiple functional teams were involved for creating the accounts. Lot of drift, lot of, what is the authentic configuration was difficult to find. So once, you can say, from establishing the requirements to configuring the baseline settings to forming the network capability and change management and quality process took us weeks of time. And now we focused on the automation. We basically, whole process of setting up the new accounts got automated. And now we are able to provide secure, well-architected, and ready-to-use accounts to our customers. And the timing reduced from days or weeks to hours, an hour or so. Now, using automation, creating multiple accounts with least privilege principles simplified our all operational issues. Less number of tickets are flowing in now. And it also provided the benefit like security, resource isolation, you can say the smaller blast radius, and it simplified the chargeback billing. So billing became simpler along with this automation flow that we did. Let's look at the architecture high level. So we standardized and automated this account creation. So how we did that, like before you can see this picture, once we get the attributes, all the attributes for account configuration, I mean the org settings, taggings, or you can say IAM information that you need, the logging configurations. So we are using AWS foundational service DynamoDB for that. So all the information is saved there. Then this foundational service DynamoDB sends the stream events to that triggers the Lambda, and then we have a CI/CD pipeline, and then basically that pipeline executes. Once that pipeline executes the cloud formation templates, and these cloud formation templates in terms of a stack sets are creating, you can say, the networking, logging, security, and identity stacks for each new accounts. We have organizational-based account creation. So all the organizational-based SCPs, for example, are inherited. CloudTrail information is also inherited. Typically, we have 3 accounts per application: dev, test, and prod. Also, we provide that, like you can say, isolated environments for experimentation for certain teams. So this framework, the standard account creation framework, for every account that included the, you can say, the end-to-end identity management, logging, shared services, and even connectivity back to the on-premises. Now let's talk about the shift left. We also provided end-to-end secured and compliant DevSecOps flows for our teams. So what can happen is they can easily be more productive. They can release their code faster with higher quality. This DevSecOps flow that you can see now basically empowered our consumers, and even some of our cloud team members are also using this flow to continuously implement security while building their products. So you can see every code base, every change that we are doing in the code base goes through a series of scans and series of tests before a successful build. So if you look at the high-level illustration here that we have, once commit is done, code scan is being done for secrets. We have a ISE validation and security scans. Each places we have a validation checkpoints, and you can say, before provisioning, all the resources are scanned for security policies and controls. You might know already the proactive controls. So all these proactive controls to ensure that only the compliant resources are provisioned. Shift left helped us overall in establishing the culture of collaboration, and it improved overall the security posture of our cloud workloads. Now, as you heard, we also utilizing the preventive controls, detective controls, and responsive controls. Let's talk about the preventive controls now. So preventive controls are first line of defense, and that helps us to help prevent any event. Like you can think of a segregation of duties. Like for example, you want to put like some limit privileges and you want to help establish some logical boundaries around that. SCPs are the great tool for that. So SCPs basically allow you to set up the guardrails in each of the member accounts. So now some examples that you don't want to operate in certain regions, for example. You don't want certain accounts to use some conditional approved services. You can basically create an SCPs at OU level for them. Another use case can be centralized logging bucket. Like centralized logging bucket should never be deleted, for example, right? So for that, you can restrict it by updating the SCPs. Now, another good example is like, for example, the S3 bucket should have all block public access settings enabled. So what we do then, you can see we write an SCP, we provide basically at that parent OU level. So we created an SCP for that S3 bucket, denying the S3 public access, wrote that policy, and then once we deploy that at the root parent OU level, then it is inherited to all the member accounts. Now, key takeaway from this is SCP is a very powerful tool. If you have multiple accounts and you are in this journey and you have a different OUs, then you want to empower your feature teams also, then SCP is the way to go. Detective controls. Now, detective controls are second line of defense, and this helps us in finding the security issues. Detective control can alert you for any misconfigurations or the drift or any potential threat. Now, first of all, like you want to look at like any overprivileges or any lateral movements. So then least privileges can be easily verified and detected in your flow. Any configuration drift. Any configuration drift means you are basically want to look at the misconfiguration. Any role is misconfigured. There is a bucket is not encrypted, for example. All those can be your potential threats. So you can do the visibility using the detective controls. Detective controls also help you to meet regulatory and compliance needs. Let's look at some examples. For example, you want to detect whether an Amazon SageMaker notebook instance allows direct internet access. You want to detect that. You want to avoid that. So these controls are very good for be more compliant. Then similarly, RDS instance you want to check whether RDS instance is encrypted or not, whether your access keys are rotated or not every 90 days. So detective controls are a very good tool for that. Detective controls are foundation to the governance, and it enables, you can say, better incident response handling. Now, as we mentioned, let's talk about the least privilege IAM strategy that we are using. We are using IAM AWS Identity Center, basically to log into the AWS Management Console. We are enforcing MFA to access to everyone whoever wants to access the AWS console. We are using Vault to manage our root credentials. Basically, we shifted some delegations of permissions from permission boundaries to SCPs. We are utilizing standardized permission sets. So we created just-in-time or on-demand automated access for our cloud operations team. Now, earlier, like for example, we were getting like a lot of tickets for somebody has even like AD group to IAM role mapping. Now we basically created the self-service IAM process for that. As you can look in this architecture, high-level architecture. So right now the account owners themselves can go in, they can log into the self-service portal, and then utilizing the IAM center, and then they'll be able to provide the AD group to the IAM role mapping themselves. Similarly, right now you can see access analyzer. We are also utilizing access analyzer for the verifying any IAM overprivileges overall. In addition to IAM access analyzer, we are also using the any third-party security tools for that. So any overprivileges are being monitored regularly, and then the consumers are being notified immediately, and then being followed up, or otherwise some cases we have even auto remediation for that. Another important thing, we have a self-compliance as a service model. That means as you saw, that as soon as new account gets created by the process, and once that automated process is completed, we create the equivalent project in the third-party security tool that we are using, and then we map it to the project reader role. Project reader role is the least privileged role that we assign to them. That means they can only see their non-compliance issues, their alerts. They will not be able to see someone else's information there. So similarly, that specific subscription or account gets linked to the project, and then capability for them is right now like visualize only your alerts. So as you can see here, we are utilizing a flow where we are updating our JSON file. As soon as new account gets created, attributes are updated, JSON file gets the new data, and then S3 bucket gets updated. And then we are using a service, Amazon Event Bridge, where it's waiting for the events, and then Lambda gets invoked. Certain APIs get interacted with the security tool. Using those APIs integration, then we give capability to our consumers. All those consumers can utilize this self-compliance as a service model themselves. Now, Merck has also developed own auto-remediation framework that integrates with the, again, third-party security tool to identify non-compliant and misconfigured assets, and it auto-remediates the critical issues. Now, we are using serverless architecture. This serverless architecture for this flow sends the auto notification to the consumers immediately any non-compliance is detected, and also it does auto remediation. Like for example, you have SNS topic, so you can look at the flow. In AWS, any misconfiguration is detected, then the tool gets that information, and then our SNS and SQS getting the messages, our SQS queues up the message, and based on that, Lambda gets triggered. And that Lambda basically invokes the playbook that we have for the specific, you can say, policies that we have created. So that playbook executes, and then remediation completes for that specific policy or control that is in place. We are also utilizing a service, AWS service, AWS step functions, that is used as a state machine basically. That means somebody has a production release in like 2 weeks, and they don't want to remediate immediately. They want to request for more time. They can fill in the form, and automatically DynamoDB gets updated with that information, and the state machine keeps the timer for example, for 2 weeks, and then gives them capability to remediate after the specified time. And that is the, you can say, identify, notify, evaluate, auto remediate, and then we are also giving capability to our consumers as self-service remediation. So in summary, as you saw, our business stakeholders are empowered to securely innovate. Automation that you saw, automation helped us in enabling business agility while still enforcing governance and controls. Self-enablement and automation helped faster experimentation capabilities. And all this is done with least privileges. We improved our security posture. We improved our compliance with the flexible use of AWS services. Thank you. Back to Harvey.
Great. Thanks, Jack. Thanks for this insightful presentation. And as you heard from the keynote from Debbie Wheeler of Delta Airlines, no matter what industry you are in, some of these foundational controls of automation, enforcing consistency with the security model in your DevSecOps, and then doing the shift left is helping Delta, is helping Merck, and even now I'm going to invite Alex from Fidelity Investment on how they are taking this journey even forward and even further to scale and provide benefits to their business stakeholders. Alex?
Thank you very much, Harvey. Hello, everyone. My name is Alex Batts. I'm from Fidelity Investments, and I'm the tech lead of our AWS Security and Service Enablement team. Together, we're going to be walking through Fidelity's journey with AWS IAM from where we began 7 years ago to where we're going tomorrow. And I'm hoping that along the way, as we address some of the issues that we ran into trying to scale aggressively, you'll be able to take these same lessons and steer around the obstacles that we've been facing lately. So let's rewind all the way back to 2016. When Fidelity first started our cloud platform team centrally, one of the things that we wanted to do is take inventory of our AWS accounts and start assessing risk. And we pretty quickly identified that developers having native access to AWS's IAM API was something that we just couldn't let people do. We can't let our developers run with scissors, so to speak, because first of all, we can't expect every developer that we have to become an expert in identity security. And we also realistically recognize that for a developer, you're going to prioritize functional application over security best practice. It's almost always going to be a second place. So that meant for our initial strategy, we denied native access to the AWS IAM API, and we had a very patient two-person team manually review and deploy everybody's roles and policies. You can imagine how well that scales. So pretty quickly, we landed on our initial solution to fix this problem, self-service and automation. You may notice a theme with Jag's presentation. So we created a REST API that would automate the rules engine for the manual review process that we were doing ourselves. And with a couple of other bells and whistles like a custom authorization database and a serverless backend, we were able to allow our developers to automate management of their IAM resources end to end. That system is still running today. It's approaching 2 million deployments. It carries out about 3,000 either create or destroy operations daily. And it's been adopted by every team at Fidelity that works in AWS. It's the only way that we allow for people to manage their IAM roles and policies. And that sounds great on paper. And for a long time, this API has been attached to me personally, and people call it my baby. But what I've noticed is recently, my baby has grown up and is becoming an awkward, rebellious teenager, so to speak. I wonder where it got that from. So let's talk about lessons learned. One of the first things that we learned is that we ran into this problem of one size does not fit all. And what I mean by that is a lot of the manual review process that we did, in order to facilitate people quickly and consistently adopting IAM to build their applications, we basically mandated 2 policies that had to be attached to every role that served as a rudimentary permissions boundary before that was a capability that was available. And those 2 boundary policies created a broad sandbox of permissions, and we basically told our developers anything that you configure within this space, we will consider compliant, and you can manage through self-service. Well, over time, as you scale out and people want to innovate more and more with new services and features, that you start to run into the snowflakes and the edge cases, things that challenge your controls. So then you have to build in a way to manage exceptions and enable self-service and agility on top of your existing controls. And as exceptions start to crop up more and more, your control goes from a strong security control to a suggestion or a guideline. The other thing we were doing is we were scaling up aggressively and exponentially, but without really following through and iterating on those rules engines and strategies to kind of steer our IAM the right way. We broke 200,000 roles deployed across 1,400 AWS accounts, and that number is continuing to grow. We found that we were running into policy limitations with the amount of space that we have within our service control policies, the number that we can attach to our organizational units. And overall, our changes to global IAM security became very high risk. And on top of all of that, when our internal and external auditors come and look at Fidelity's environment in AWS, it becomes a very complex story to tell of when looking at a single principal, what access do they have in total, and should they have that access, which is the key piece. So in order to address these problems, we decided to essentially commit to a pretty dramatic change in strategy. To break down the very large problem that we had in front of us, we decided to focus on 2 key pillars. The first one was addressing the kind of give and take that we did with least privilege and business agility, because we had created with those 2 boundary policies a giant sandbox for people to play in, but really what we wanted people to do is iterate towards least privilege. And we just found that that wasn't happening like we wanted it to. So our first pillar that we focused on was let's create a new framework that we can use to establish smaller baselines for what privileges people can grant themselves. Second, we identified a risk with the action IAM pass role. And if you're not familiar with it, pass role is the action behind a lot of AWS services when you want them to run as a particular identity. So think Lambda or EC2 with instance profiles. If you can supply a role to an AWS service, pass role is the action that carries that out. And pass role is very tricky. For one thing, it's not logged in CloudTrail, so it's hard to get at-scale analytics of how it's being used across your organization. And two, it doesn't support tags-based conditioning. So if you have an interest in controlling it, like say if I want to prevent my member accounts from being able to use my administrative roles to run their EC2 instances and effectively escalate their permissions, if I want to do that, I'm kind of steered only towards limiting based on resource ARN. And so those two pillars and strategic guidelines led us towards something that we're calling the IAM Taxonomy, which is our strategy moving forward. Before we talk about taxonomy in a cloud identity context, I'm going to take a couple of steps back and talk about what a taxonomy even is outside of cloud. My favorite example for this is biology, specifically the duck-billed platypus. If you have an image in your head of a platypus, you might recognize that they're very awkward-looking creatures. They have fur, but they also have a beak, and they lay eggs, but they look vaguely like a beaver. And so for the layman, this is a very confusing animal to approach and would probably require a lot of observation to be able to understand what it does. Biologists solve this problem by applying taxonomy to animals. And so if you approach a biologist and tell them that this is a platypus, it's a monotreme, don't worry, there's no quizzes, then they are going to recognize that that means that it's a mammal that lays eggs, and they'll know other animals that it's related to. They'll know a lot about what makes it fill the role that it fills within the animal kingdom. And likewise, you can have those one-word designations like monotreme that tell you some information, but you can also go significantly more granular, create hierarchies, and create extensions onto that framework. Most people know that under that same taxonomy, humans are Homo sapiens, but we have a full designation that's Animalia, Chordata, Mammalia, Primate, Hominidae, Homo sapiens. Every single word in that taxonomical classification tells scientists a wealth of information about who we are as animals and the role that we fill in the rest of the world. My high school biology teacher would be very proud of me for getting that one right. So all of that is to just illustrate that when you have ways of classifying things and making that classification opaque and transparent, you're able to take what looks like a 250,000 role environment in something like AWS and break it down into considerably smaller problems. So the example that I mentioned about controlling pass role, you can see in this policy snippet, if I have to specifically call out all the administrative roles that I want to protect, then there's going to be some that may not strictly fit that naming convention. You might wonder, why is the platform team role being protected? What rights does it have that I want to protect so strictly? But if I can apply a classification to them, I can not only condense this into a very intuitive policy statement that says something to the effect of role/admin/star and wildcards everything after. I also make that value of that statement very opaque and transparent. So auditors can say, aha, this statement is the statement that is responsible for preventing our users from using our admin principles where they're not supposed to. That probably sounds great on paper. I actually have a simple example, a three-tier taxonomy that we'll walk through now so you can kind of get an idea of how this is developed and applied. So picture, if you will, that you've looked at the inventory of identity that you have across AWS, and you've identified three different buckets. You have deployment roles that are used to provision infrastructure for your applications. You have interactive roles that are used by end users to log into the CLI or to the console. And then you have runtime roles that are being used by applications and AWS services. And immediately, when you're looking at how these are supposed to be used, you can make some authoritative decisions about the permissions that they should have and use that to craft permissions boundaries. You can say things like, well, my deployment roles can create and delete databases and infrastructure, but they may not need access to data. And likewise, my application runtime roles, those may need access to data, but they probably shouldn't be able to delete a database instance. And so you can start from that giant sandbox that we had with those two permissions boundary policies that was trying to accommodate every use case. We can narrow that scope and focus in on specific use cases and treat them as personas or as use cases that we are accommodating. Likewise, after we've solved what permissions somebody should have, there's supplemental controls that you can start to ask yourself questions about for each of the extensions of your hierarchy, or the extensions of your taxonomy beyond just AWS IAM, right? You can think about, for federated principles, who should have access to different roles. For deployment, I probably don't want human end users, but for interactive, I necessarily will have them. And you can think about things like an application role probably wouldn't need a federated trust at all, because I wouldn't expect people to directly log into something that my app is using at runtime or that a Lambda function is taking advantage of, right? But that also demonstrates, that statement right there demonstrates one of the key foundational things that we are doing with this taxonomy is we're really just creating a framework that is extensible and that can be expanded upon to accommodate more and more edge cases. Instead of exceptions to our controls and weakening our security posture, it's developing new ways to accommodate new use cases in Snowflakes as they come up. For applications, if you're running in AWS native space, then that statement of I don't want federated principles may be true. But if I'm running a hybrid application, if I have some on-premise system that needs to access a Dynamo database, then I may expect to see federated trust. And so I can introduce a new class. I can make a hierarchical division and say I have my runtime native roles that are going to be used purely in the AWS context, and then I have my runtime hybrid roles. And the difference, the discriminating difference between them would be what kinds of trust policies I consider compliant. And as you recognize more and more use cases, things like data scientists that are going to need interactive access in a production environment, and operational teams that are going to need break glass access for incident response, and they may need just-in-time access and all kinds of other multi-factor, the extensibility of what controls you can apply. It all just becomes a series of questions that you ask for each of those personas that you identify. And you can grow to meet the needs of the business as the scope of the business expands. For a platform team like mine, so like I mentioned, I'm the AWS Security and Service Enablement team. One of the biggest things that we do is high-risk changes to things like service control policies. And if anybody else works in finance, then you're probably familiar with this kind of sense of during market hours, everybody kind of plays like offensive linemen, where basically all we want to do is we want to block, we want to create a pocket where our applications, the QB in this case, can have time and space to work and deliver value. And then after market hours, it's just circus plays and everybody's throwing Hail Marys. And a lot of times, a lot more risky things can occur. That joke was for my dad if he watches this, and I sure hope it was correct because I do not play football. So we'll see. But using tools like CloudTrail Lake, we can take some of what would be circus plays effectively for our changes to things like service control policies and do pre-flight and post-flight data analysis to take a data-driven approach and become confident in the changes we're making. You can see in this query snippet I have in the top right that using that path-based, that resource path-based taxonomy, if I want to make a change that, let's say, denies the ability for interactive users to delete a Dynamo instance, but I'm concerned about potentially impacting deployment roles that naturally would need to be able to delete those databases and rehydrate them. What I can do is before making my change, I can query CloudTrail Lake for near real-time statistics on what is the current error rate for an interactive user deleting a Dynamo instance. And likewise, what is the current error rate for a deployment role deleting a Dynamo instance? After I make my change, because of the close to real-time delivery that CloudTrail Lake gives us, we can do analysis and look for a spike that we would expect to see in the error rate for interactive users. That tells us that our control is taking effect in the way that we intend it. We can also look for, we would want to see a relatively stable rate of errors for our deployment roles, because that would be a signal that we have not impacted the wrong user base. If you see a spike in that, you can use that to proactively roll back a change that had an unintended impact, rather than having to be reactionary to your teams telling you that they're running into problems. And for a platform team, that's incredibly valuable, and it helps us convey the story of the changes that we make to the business in a more concrete fashion. Those that are deeply familiar with IAM will be also familiar with the idea that making a change to a naming convention or adopting a resource path-based strategy is not an in-place change. When you update the name or the resource path or a role, necessarily AWS actually deletes and recreates it. It has a new canonical ID that will break resource policies and trust policies. And so you can imagine when we are talking about the scope of around 250,000 roles, the business impact is immense. And so that's something we're not taking lightly with our strategy. Key to this story is finding a North Star to focus on. In our case, providing native IAM access and constructing permissions boundaries that will let us get out of the way of the business. And then finding metrics that let us capture the value proposition along the way. For us, we decided to focus on the entire lifecycle of identity in AWS. And that means not only looking for things like IAM Access Analyzer findings as a recognition of risk reduction, but also looking for a downward trend in exceptions to our security controls as we start to formally support and govern those edge cases that before just necessitated removing our boundaries. And we also, critically, want to measure the friction that we're creating for our developers. So today, like I mentioned, that REST API, it delivers a lot of value and it's had a lot of success, but we get very frequent support tickets from people that are having trouble engaging with AWS IAM in an intuitive way because our process doesn't match what AWS documentation will tell you to do, or it doesn't reflect their personal work history at other companies. And so that learning curve, if we can get out of the way and we see a downward trend in the number of support tickets related to IAM, then we've also delivered value in our developer experience. And as we make that journey, continuously measuring and keeping ourselves accountable to those KPIs is part of how we hope to evolve our strategy, not only to land in more secure posture, we also want to go from being an obstacle in the way of our development teams to partners in delivering security and making it intuitive and incentivized for people to iterate on their access, drive towards least privilege, and make that journey together with us as a governance team. Thank you very much for your time, and I'm going to welcome Harvey back up to close us out.
Thank you so much, Alex. This was really insightful and really talks about how you have evolved your journey over a period of time and how the scale, right, like the multi-account strategy that you are deploying, the 250,000 plus roles, it continuously evolves. So this is something that you all can take away from, learn from Alex and Fidelity, see how you can deploy some of these architectures, some of these principles, the whole taxonomy-based framework to enable security at scale. Here are some few resources for you to take a look at a later point of time and learn more, try some more services, what are the different capabilities that are available from AWS in your environment in there. And now I would like to invite Jag and Alex back and just talk about if there are two key takeaways you want our audience, our customers over here to go away with. What will be those two key takeaways? Jag, first you.
Yeah, thank you, Harvey. Yeah, so I will say first takeaway is like automation. Automation is the key to scalability. And if you are in your cloud transformation journey, if you have opportunity in your workflows, you should automate as much as possible, whether it is an auto remediation workflow or whether it is an auto tagging solution. Second takeaway is about the shift left. As you saw, we are utilizing shift left. Shift left basically can move all your testing, all your security scannings, IAC, infrastructure as a code scanning, everything early in the cycle will help you deploy skilled resources end to end. Thank you.
And from my side, I think my first takeaway would be to measure early and measure often. If something can't be measured, it can't be improved. And a lot of times I hear people talk about security when they're making strategy or policy decisions. They say things like, we'll make this policy and people will align because we're security and they have to. And in most cases that's true, but I think we shouldn't accept that. I'm a firm believer that security does deliver value to the business. And if you find a way to measure that and you continuously deliver that story to the business, then you're giving people a reason to work with you instead of just tolerate you. And the second would be, I really want to underpin the fact that least privilege is an iterative process. And if you want to balance agility with that journey to least privilege, you have to be willing to let your developers not get it 100% right the first time. Personally, I've been working in AWS IAM for 7 years now. I basically think in Cedar on my off time. And so I still find tons of problems with my roles the first time I deploy them. And it takes that iteration process, it takes follow through and understanding that it is going to be a journey and you're going to get there eventually, but you can't expect it on day one. If you do those two things, then you end up creating a story where people will be excited to engage with IAM and they'll recognize it for the incredibly complex ecosystem that we all engage with.
Well, Thank you so much. Thank you so much, Alex and Jack and Val also
Thank you.
for talking through these different experiences and how the journey has evolved. So we hope that you are able to apply some of these findings, some of these learnings to your environment. And thank you so much. Have a great event and please provide us with the survey feedback. Thank you.